In the previous video, we looked at how you can use the natural form of the landscape to create a pond by placing a bund across a constriction in the landscape. This video, we're going to use a similar approach, but we're going to accentuate the size of that pond by excavating part of it. So instead of just using exactly the landform that's there, modifying it slightly to increase the potential storage volume of the pond. So we will go through the same steps as we did in the previous video, and if you haven't had a look at that, then I recommend running through that workflow first. But we need to have a look at where we thought we would have our pond, and instead of having this gently sloping gradient up here, what we're going to do is look at creating a flat bottom to the pond here. So choosing the lowest point of the pond and then excavating this whole area out, so this is all a flat base, so you get some additional storage. Right, so we're going to select this contour here as the extent of the flat area of our pond. You could draw a polygon to the area that you want, but just for demonstration purposes, we're going to choose this location here. So using the feature to polygon tool, as we did in the previous video, we're going to choose our bund again as one of our input features, and the contour DTM. And remember that this will only run the tool using the selected contour. It won't run it using every single contour in that output. We're going to call this pond base and run that tool. So this outputs with the polygon covering the area that we want to be the flat bottom of our pond. Next, we're going to use the raster to point tool, and all this does is to convert each of the values of this raster into a point with the same value, and that's so we can more easily edit the values of those points. So choose the DTM covering your pond as the input, and in the previous video we used the extract by mask to get that DTM for the pond. Leave the field as the value. We will name this DTM pond point, and just check in the environments that you've got your output coordinate system set, and you've got the snap raster to your original LiDAR dataset. Okay, so you can see that the output generated is a set of points, and each point covers one of the cells from the raster. If you open the attribute table of that point data, you can see that the height data from your raster has been put into each point here. And this is what we can use to start editing the points and lower them in the area of this polygon that we want to be the flat base of our pond. So the first thing we'll do is to sort these values by their ascending value. So we can see that the lowest point in our pond is 168. So what we're going to do is to modify all of the points that sit within this pond base area, and we're going to make them all 168. So we're going to create a flat bottom to that pond. So the next thing that we have to do is to select the points that lie within that polygon area, so the area that we want to use as the base of our pond. So if you use select by location and choose the DTM pond point feature as your input and select intersect as the relationship, and the selecting feature is we want to use the pond base, and you can leave the rest of the defaults as they are. So all that does is to select the points that lie within that polygon area. And you can see in the attribute table that those points are highlighted, and the rest are just left as they were. So if you right click on that column, we can then calculate the field. So we can edit the values of all of these points by putting in the value here of the grid code. So the grid code is the height of the raster, essentially. So what we said we would do is to set all of the points that lie within that polygon area to the value of the lowest height. So we're going to set it to 168. So run that, and you can see now that all of the points that were highlighted within the area of the polygon have now been changed to 168, but the rest of the values are unchanged. Okay, once we've edited those points, we can convert the point data back into a raster, and to do that you use the toggle to raster tool. So if you choose your elevation point data as the input for your feature, it's point elevation as the type. Output surface raster we'll call pond DTM excavated. The output cell size, we know that our original DTM of covering the pond, if you go into the source and the raster information, you can see that the cell size is 1. So we'll use the same as that. The output extent we want to be the same as the pond polygon, this one here, the purple one, because what we don't want is to run this tool and it to extrapolate values all the way around here. We only want values that cover the extent of that pond, so that's what we've done there. You can leave these as the default, however we need to change this primary type of input data to spot data. We can also leave these as the defaults. Into the environments, again check that your coordinate system is the one that you want. The processing extent, we'll choose the extent of our pond again. Cell size, minimum of inputs, we'll choose a mask of the pond just to make sure that we don't get any values outside of that location, and we will snap our output raster to our original LiDAR, and you can leave the rest of these inputs as the default. Back in the parameters, just to check that the field that you have selected here is the grid code, because that's the field that contains the elevation data that we've just modified. Okay, so once you've made sure that you've got your parameters and your environments set up, like that, then you can run the tool. Now I'll just turn off some of these other layers so you can get a better sense of the output. Okay, so you can see that it's created a raster layer as the output with a flat bottom at around 168, rising up to the higher ground here at about 169. So there's a meter difference between the bottom of the pond area and the top. Next, what we can do is the same as we did in the previous video, using the surface volume tool. If you input your excavated pond DTM and choose output text file as the volume, we'll choose below the plane again as our reference plane. Like in the previous video, what we're doing is to put in an imaginary flat surface at the height of the bund, and then looking what the volume is between that flat surface and the bottom of the pond. So for the plane height, we need to choose the height of our bund again. So if you put on the contour, we were working with this contour here, which was 169. So if you put that into your plane height, because that was the height that we were assuming the bund was going to be. So we're assuming that if we put in a bund across this ephemeral channel and we allow water to fill up to the maximum height of that bund, what's the volume of water that we're going to get stored behind it. So if you run that tool, and like last time, it pops out as a standalone table, which you can open. Just put it down here. And we can see that the estimated volume that we're going to get from that pond is about 100 meters cubed. So the previous pond that we did, where we just used the natural form of the landscape, we were getting about 70 meters cubed. But now we've excavated down and made the base a bit bigger in this pond. We're gaining about 30 cubic meters of storage. So you can start to see how this would be a useful tool to compare how much volume you're going to gain if you start excavating that natural landform. Okay, so now that you know you get about an additional 30 cubic meters of volume, that also gives you an idea of how much spoil you're likely to generate by excavating out at the base of this pond. So you can see whether it's feasible to deal with that amount of spoil on your site. So that's about it. Thanks very much.